At the end of the summer, Kyle decides to invest his summer earnings in a CD, which is a certificate of deposit, earning 2.3% monthly. If he made $1,250 per month for each of the 3 months of summer, how much will he have when his CD matures in 5 years? So it kind of sounds like he's making monthly payments, but let's take a closer look. If he made $1,250 per month, there's the per month thing that's making me think that we're doing monthly payments, and that's for each of the 3 months of summer. So 3 times he's making the $1,250. But at the start of this problem, it says at the end of the summer, he decides to invest his money. So through the summer, he was just keeping it somewhere, maybe the checks on his counter or something, and then he decides, well, maybe I should invest my money. So it looks like he's investing it one big chunk of money at the end of the summer. And so we need to find out what that big chunk is. So if he made $1,250 per month, then we can multiply that by the 3 months of summer and see what he got. $3,750. So now he has $3,750 at the end of the summer, and he's going to deposit that into a CD earning 2.3% compounded monthly. How much will he have when his CD matures in 5 years? And I happen to know, and I don't know if you know, but a CD, a certificate of deposit, is something that you purchase with a big chunk of money and then you leave it sit. You don't add anything to it, you don't take anything out from it for that period of 5 years. So that really tells me that this is a general compounding formula problem. So I need that general compounding formula. And if I look at my formula sheet again, there we are. I see general compounding right there, and I have 2 choices. One is solved for the amount, and the other is solved for the present value or the starting amount. And if we look up here, present value or starting value is what that PV stands for. And so my A is probably the one I need because I know the starting value, the $3,750. So I need this first formula. All right, so I'm just being lazy. You should probably write out that formula yourself. I just want you to see where it is on the formula sheet and be able to identify which formula and what all the parts are based on what's on that formula sheet. So for this one, the A, we don't know. The PV, that's going to be this 3750. We also need to know the R. So I see an R here, and compounded monthly, that's my N, and time in 5 years. Okay, so if I plug all those things in together, I have A equals 3750 times 1 plus my R of 0.023 divided by my N of 12 raised to the N of 12 times the 5 for the T. Now, I strongly encourage you to read your problems a couple of times to make sure you really understand what they're talking about, because this problem, for example, if I just saw per month for each of the 3 months of summer, I might think that Kyle is just investing with an annuity for 3 months, which doesn't make a lot of sense, but if I wasn't reading carefully, I might not notice that he was adding up all those deposits for the summer and then finally taking that lump sum and making a single deposit into a CD and then compounding monthly on that CD. So here I have 3,750 and 1 plus 0.023 over 12 raised to the 12 times 5. I need to figure out that 12 times 5 first, which is 60. I'll write that down. And then I will go to the 0.023 next, divided by the 12, and add the 1. And if I'm writing a lot of steps, then I would probably put a step here, 3750 times 1.001916, repeating to the 60th power. I'm ready to raise to the 60th power, so I use the to the button right here. To the 60th equals, and then the next thing is to multiply by the 3750. So I end up with an ending amount of, the next digit after the 6 is a 2, so I'm going to leave the 6 as it is. I have $4,206.56. And so he started with $3,750, and if he leaves it sit for 5 years in an account that's earning the, 2.3% interest, he's actually going to gain quite a bit of money. That's like $500 in interest. So that's a pretty good deal.